Hello, assalamu alaikum, good morning, good afternoon, good evening, good night. My name is Dr. Muhammad Nurhilman Rabbani, and today, right now, I'm gonna be talking about how to perform the operations of addition, subtraction, scalar multiplication on vectors represented as directed line segments in 2 space, and on vectors represented on Cartesian form in 2 space and 3 space. 2 space means 2 dimension and 3 space means 3 dimension. As you can see, Mr. Sean is the best. So, okay, first things first, the addition. Let's start with the sorry, my handwriting is quite bad. Let's start with the easiest one, the addition of vectors. Addition of vectors. 2 vectors, in fact. 2 vectors, of course. How can you add 1 vector? Of course, 2 vectors. The vector addition, S. S is the vector for the vector. The vector addition S of 2 vectors of S is equal to the addition of the 2 vectors A and vector B, right, is denoted by A plus B. Vector S is the addition of vector A and B, and this is called the sum of A and B, right? This is basically the general rule, not the general rule, but yes, that. Now we can do it geometrically. By doing geometrically, now we're gonna talk about addition of vectors in 2 dimension geometrically, not algebraically, but geometrically. Okay, geometrically means using pictures and illustrations, not numbers and letters. Okay. Now to find the sum, or as some might call it, the resultant of 2 geometric vectors, we place the second vector with its tail on the tip of the first vector, which is the head. Let's say this is vector B, and this is vector A. Now to add vector B and vector A together geometrically in 2 dimension, we place it head to tail. This means we move either vector and put the tail on the head of the other vector, and yeah, let's add A plus B. I'll give you an example. A, okay, vector A geometrically added with vector B. This is not 100% accurate degrees of accuracy, but you'll understand what I'm saying. Like this is vector B. As you can see, head to tail. Okay. Now the resultant of the vector is you draw another line from the first tail, the tail of the first vector, to the head of the second vector. This is the resultant, or the sum of vector A plus B, also known as, in this case, the vector S. Alright. Okay, now we're going to talk about the parallelogram rule. You can also use this rule to add 2 geometric vectors. Okay, let's say we got vector A. Vector A looks something like this. And we got vector B. Okay. Now to add this vector using the parallelogram rule, it's always hard to say that, we position both vectors with their tails at the same point, which means their tails should be at the same point, touching. Let's do that. Position both vectors with the same tails pointing. This is vector B, and this is vector A. We position them with the same, their tails at the same point. Okay. Now we build a parallelogram using both of these sides as such. Now to build this one, I'll use the dotted line. Okay, and then we build a parallelogram as shown, like that. The resultant vector, the resultant vector is given by the diagonal of the parallelogram, starting from the common tail point. This is the resultant vector from here until here. From the tail until it's a diagonal. That's the resultant vector. This is vector A plus B using the parallelogram rule. Okay. Alright, now we're gonna do vector subtraction, the subtraction of two vectors. Now the subtraction operation between two vectors, vector A and vector B, can be understood as a vector addition between the first vector and the opposite of the second vector. Minus. In other words, I can rewrite this as the first vector plus the opposite of the second vector, vector B. But let's say this is vector A and this is vector B. We want to add that we want to do this A minus vector A minus vector B. It says vector A, okay. We're putting this heads to tail. Okay. Add the opposite of vector B. Now the opposite of vector B goes this way, like this. This is the opposite of vector B. Okay, heads to tail. We'll put it to tail, opposite of vector B. This is vector A, and this is negative B. Now the resultant vector is from the tail of the first vector to the head of the last vector. This is vector A minus vector B. And that is the subtraction of two vectors. Okay, now we're going to talk about the multiplication of vectors by a scalar. Vectors by a scalar. Alright. Let's say vector v. By multiplying vector v by a scalar of k, k is a scalar, okay? We obtain a new vector noted k. This multiplied by k, kv. This is new vector. If we multiply vector v by a scalar of k, scalar is any number, 1, 2, 3, 4, any real numbers. By v, we get a new vector called vector kv with the following properties. Kv has the same direction as this. Kv has the same direction of vector v if k is more than 0, which means if k is a positive number, then kv will have the same direction as vector v. Now if k is less than 0, in other words, if k is a negative number, then the direction will be opposite. The direction of kv will be opposite to the original vector v. Let's draw a vector v. This is vector v. All right. Let's say the vector v has a unit of 5 centimeters. K is equal to 3. Okay. Now we multiply this vector by k, which means 3 times the vector v. 3v. My bad. We want 3v. Okay? So 3v means 3 vector v's. So if we have a unit, we will have a vector that is 15 centimeters long. V, V, V. Between 3 vector v's, which is one whole vector of 15 centimeters. If the vector has a unit, depends on the unit. That is the multiplication of vectors by a scalar.